Hello dedicated learner, and this is our first module of lecture 1. In this lecture, we will introduce the concept of learning. We will show that there are many similarities between animal and machine learning. We will make an attempt to answer the question, why do we need machine learning? Finally, we will introduce some characteristics of data. To answer the question, what is learning? We begin with an example of animal learning. When rats encounter food items with novel look or smell, they will first eat very small amounts. If the food produces an ill effect, the novel food will often be associated with illness, and subsequently the rats will not eat it. Here's the definition. Animal learning is the alternation of behavior as a result of individual experience. When an organism can perceive and change its behavior, it is said to learn. In terms of systems theory, this process could be represented by the shown diagram. The food is an input to the system, and the experience is an output of the system that fed back. This feedback updates internal states of the organisms, and the organism learns if this particular food should be avoided in the future. Next, we turn our attention to a trivial spam detector. As we will see, it is very similar to the way rats learn to avoid poisonous baits. The machine will simply memorize all previous emails that had been labeled as spam by a user. Here we have a diagram that looks very much like the one for animal learning. The only difference now is that the knowledge is represented by a database. Each record in a database represents a spam email previously labeled by a user. Every incoming email serves as an input to the system and is compared against all records in a database. If there is a perfect match, the email marked as spam and trashed. Otherwise, it is passed to inbox. In case the email turns out to be spam, a user manually labels it as spam, which serves as a feedback, and the database is updated. Now, think for a second why such learning algorithm is trivial and what we can do to improve accuracy of spam detection. The weak point of this algorithm is in its requirement to have a perfect match between an incoming email and one of the records in the database. A small change in the incoming spam email and the email will be passed as ham. Some approaches to improve this algorithm we will discuss in our next module. The next question we want to answer is, what are the areas that benefit from machine learning? There are a number of areas where machine learning makes tasks easier to solve. These are definitely routine tasks such as speech recognition, image understanding, and driving. When an experienced driver driving a car, she is doing it routinely. These routine tasks previously were hard, if not impossible, to solve for a computer, while now, thanks to machine learning, they are efficiently solved. The other class of tasks are the tasks that require search for patterns and are simply beyond human capabilities due to a large size of data arrays. For example, astronomical data, medical data, and in particular the tasks of turning medical archives into medical knowledge. Other examples also include weather prediction, analysis of genomic data, and many more. One of the main advantages of machine learning is the ability to generalize on limited data. As a consequence, systems built with machine learning are able to adapt on input data. For instance, in spam detection, spammers evolve and never send exactly the same email twice. However, the content more or less stays the same. This is a perfect task for machine learning. In case of decoding of handwritten text, a computer, as well as a human, cannot foresee all possible varieties of handwritings, and thus it is important to learn just from a few examples and then adapt and recognize as many handwriting styles as possible. In fact, infinitely many. A dataset that is given for model building is usually subdivided into 3 subsets. The first one is a training set, which is a set of examples used in learning the parameters. The second one is a validation dataset. In order to decide whether to continue the training process or not, the observations from this dataset are tested and the quality of learning is assessed. More on this in later lectures. And the last one is a test set that is employed to provide an evaluation of a final model. It is not involved in training directly, unlike the validation dataset. It is only used to judge about the overall quality of training. Usually, the data is split into these 3 subsets as 80, 10, and 10, where 80% is for training, 10% is for validation dataset, and the remaining 10% is for testing. Although sometimes validation and testing dataset are combined. Generally, data types could be roughly classified into quantitative and qualitative types. Quantitative types take integer values as in color images. Specifically, color images are represented by 3 channels, corresponding to red, green, and blue colors. Each color is encoded by 1 byte integer. Qualitative data types are in turn divided into nominal and ordinal. For example, temperature, described by qualitative terms as cold, warm, hot, is of ordinal categorical type. An example of nominal data type is gender. Text is another example of qualitative data type. Before applying any machine learning algorithm, data has to be represented in a numeric format. In case of text, one approach to characterize an excerpt is by counting the number of times a certain word has occurred, which results in a histogram or a vector. In this example, we count the number of words with stems class, learn, data, cook, and train, which results in a histogram that in turn could be represented as a vector. So we have just represented an excerpt as a vector. In such a way, we are able to compare different excerpts. Also, data could be characterized in terms of number of dimensions. A time series or a sensor signal is an example of a one-dimensional data. However, if we have an array of signals of a fixed length, then the dimensions of the data is equal to the length of the signal. So in this example, the dimension of the data would be L. A grayscale image is an example of a two-dimensional data set. Or again, if we have a set of images, then the dimension of the data is equal to the product of rows and columns. Let's say that the width of this image is W and the height is H. Then the dimension of this data would be W times H. Or in other words, width times height. And here we will have 1, 2, and 3 observations of this dimension. MRI is an example of a three-dimensional structure. A table with records, for example, representing results of a medical test taken by a patient, is an example of a multidimensional data. every record is considered as a separate data point. Say here we have patient 1, patient 2, patient 3, and here we have corresponding measurements. Let's say blood pressure, body temperature, and so on. So in this case, the dimensions would be the number of columns, and the number of rows corresponds to the number of observations or the size of our data set. Usually, through pre-processing and extracting features, the dimensionality of data could be either increased or reduced. We will discuss this in our next modules. Here are a few exercises that I encourage you to tackle by yourself. Good luck!